You ever have one of those great ideas for a gadget and think, man, I wish I could just build that? Well, today, that's exactly what we're going to do. We're going on a journey from just a thought all the way to a custom-built, working piece of hardware. So let's dive right in.
So, have you ever opened up a gadget and just stared at that intricate green circuit board inside? It looks like a tiny city of components, right? It honestly feels like magic. But here's the thing. What if I told you that the whole process of making one is something you can not only understand, but actually do yourself? Yeah, really.
All right, so this is our goal. This is the mission. We're going to design and build this exact light-up circuit board completely from scratch. And by the time we're done, you're not just going to see a pretty light. You'll get the how and why behind every single step that made it happen.
Okay, let's kick things off with Section 1, our mission. Now, before we can do anything cool, we have to start with the absolute basics, the heart of any circuit, its power source.
And for this project, we're keeping things super simple. No complicated power supplies here. We're just using two standard 1.5-volt batteries, the kind you have lying around in a drawer. We'll pop them into a simple holder and boom, that gives us a 3-volt supply. That's the perfect amount of juice for the little circuit we're about to build.
All right, Section 2, choosing your tiny components. So, our power is sorted. Now it's time to pick the actual parts that are going to do all the heavy lifting.
Okay, so when it comes to LEDs, you've basically got two main options. You've got your classic through-hole kind, the ones with the long legs. They're great for beginners, way easier to handle. But then you have these little guys, surface mount devices, or SMDs, and they are incredibly small. The upside, they let you create super compact, really professional-looking designs. So you know what? We're going to challenge ourselves. We're going with the SMDs.
And when I say tiny, I am not kidding. Seriously, here's a top tip. If you're working with these, do it on a flat, dark-colored surface. Because if you drop one of these things on a carpet, you are probably never, ever going to see it again. It sounds like a joke, but trust me, it's a very real problem when you're working at this scale.
Okay, so here are the specs for the 5 orange SMD LEDs we picked out. Now, pay close attention here, because the most important number on this slide is that forward voltage, 1.9 volts. Now, why is that so important? Well, remember our battery supply. It's 3 volts. And that gap, that difference right there, is the single biggest problem we need to solve in our design.
So that leads us perfectly into Section 3, the science of the circuit. This is where we get into the nitty-gritty principles that will keep our tiny LEDs from, well, going poof and burning out.
So, to make sure all 5 of our LEDs get the power they need, we have to connect them in what's called a parallel circuit. Just think of it like this. Each LED gets its own direct line to the power source. They all see that same 3 volts. Now, if we tried to wire them in series, one after the other, like old Christmas lights, we'd need almost 10 volts to light them all up. So yeah, for what we're doing, parallel is absolutely the only way to go.
Which brings us right back to that core problem we talked about. What happens if you connect our 3-volt battery directly to our little 1.9-volt LED? Well, you get way too much current rushing through it and, poof, it'll be toast, instantly. So, how do we prevent that? Well, the answer is a simple but absolutely brilliant little component called a resistor. Its entire job in life is just to resist the flow of electricity. It basically soaks up that extra voltage and acts like a bodyguard for our delicate little LED, keeping it safe from burning out.
Okay, so how do we figure out the exact resistor we need? We use a classic, super important formula called Ohm's law. It's actually pretty simple. First, we figure out the extra voltage we need to get rid of. We take our 3-volt supply, subtract the 1.9 volts the LED needs, and that leaves us with 1.1 volts to deal with. Now, the law says we just divide that voltage by the current the LED wants, which is a tiny 0.02 amps. You do that little bit of division, and it gives us our magic number.
55 ohms. That's it. That is the perfect resistance we need to protect our LED. Isn't that cool? It's just a perfect little example of how a tiny bit of math can solve a very real physical problem.
Now here's a little real-world wrinkle. You can't just walk into a store and buy a 55-ohm resistor. It's not a standard value that manufacturers make. But the closest common value is 56 ohms. And for our little circuit, that is more than close enough. So we'll grab 5 of those, one for each of our LEDs.
All right, on to Section 4, designing the digital blueprint. We've done the math. We've got our components picked out. Now it's time to turn our little plan into an actual design that a machine can build.
So using some special design software, the whole process really boils down to these 4 main steps. First, you create something called a schematic. Think of it like an abstract electrical map, using symbols.
Then you switch over to the board layout and you start placing the physical footprints of the components where you want them to go. And finally, the fun part. You draw the copper traces, which are basically the tiny little highways or wires on the board that connect everything together.
Okay, we're at section 5, bringing the board to life. We've sent our digital files off to a manufacturer, and a few days later, a little package arrives. This is the really fun part, assembly.
You know, assembling an SMD board is kind of like being a surgeon, for real. First, you put a tiny little dab of solder paste on each copper pad. Then, with the steadiest hand you can manage, use tweezers to place each one of those microscopic components right onto the paste. After that, a quick blast from a heat gun melts the solder, and it just locks everything into place. It's so satisfying. The last step is to solder on the bigger power connector by hand.
And now, it's the moment of truth. All the theory, all the math, all that careful assembly with tweezers, it all comes down to this one single action. We connect our 3-volt battery pack to the terminal.
And it works. Just like that. The 5 LEDs light up exactly like we planned. We've literally gone from just an idea in our heads to a custom piece of electronics that is actually working. And I think the biggest takeaway here is that this whole process, from A to Z, is something that is completely 100% achievable.
Look, at the end of the day, we just built a simple little light. But these exact same steps, the idea, the calculation, the design, and the assembly, those are the fundamental building blocks for creating almost any electronic device you can imagine. So the only real question left is, what problem could you solve with your own?